Thank you to be here to assist in this weather, which is not so summer weather, in my opinion. I don't know for you, but okay. So I'm Romdhanne Bilel, and I'm working in Amadeus. Amadeus is a worldwide leader in travel industry, and I'm presenting our Amadeus migration process, which is a simulation-driven process to enhance the migration to a multi-cloud environment. And so okay. Don't know what it doesn't work. Okay, so my outline will be articulated about 6 sections. So quick introduction on motivation, what you are doing that. I will highlight the most important points about Amadeus migration process, and I will present a study case with some results, and what is the benefit of using such a research approach in industrial conditions before concluding about what you can do better and how we extend that. So the context, as you know, cloud migration has become a pivot aspect of modern IT strategies. All companies want to migrate to the cloud in order to enable to leverage the benefits of cloud infrastructure. IT migration to public cloud still and remain a problematic question. And if we added to that all the question and difficulty about a multi-cloud or hybrid solution, we have a real increased level of complexity, and in this condition, it becomes very, very complicated to understand in the beginning of our work how it will work in the cloud. So we have double motivations. We have research motivation. We need to learn to provide information how we can our application, how it will behave in the cloud. So this is a real research motivation, with the focus in the complexity of the multi-cloud migration, while trying to ensure the SLA, what is the guarantee of service for our partners. And we have the business motivation, of course. So main business motivation is providing a kind of decision aid for cloud migration, to secure business agreement and alignment, and to predict scalability and performance. Of course, all of that is included in what we can talk about risk mitigation and continuity of planning in industrial context. So in this context, business stakeholders can create the service they will provide for their final customer before even going to the cloud. Okay, so what is the Amadeus migration process? It is a simulation-driven approach that aims to manage the migration of a given application from a known infrastructure, Amadeus infrastructure, which is an optimized data center in our case, to an unknown one, which is the hybrid cloud, where we have more than one public cloud provider, and eventually a hybrid context where we have Amadeus data center in addition to public cloud. So our work starts with Microsoft public cloud, Azure, and we have a partnership with them. So using Azure tools and Azure migration process, we try to enhance this approach to include the prediction of what will happen. And in order to consider this prediction phase, we use a research solution called SimGrid. SimGrid is a well-known and developed network simulator. So it was developed by INRIA and some partners, and it allows the simulation of the behavior of large-scale distributed systems such as grid, HPC, and cloud, of course. The last version is 3.34, and it was released a few days ago. So quick view of how it works. If you use SimGrid, you need to define your infrastructure, how to define it, how many VMs, what is the characteristic of your VMs, and what is the characteristic of your network. And also you need to define the application. So you need to provide the model of your application. And this is what we do. So here I provide for you a quick overview of Amadeus migration process. So we have 4 phases: assessment phase, predictive optimization phase, migration phase, and reactive optimization phase. So since we have a short time here, I will focus on the predictive optimization phase because it's the main added value of our research work. In the predictive optimization phase, we start first by modeling the application. So we have an application that we want to take from Amadeus infrastructure and to deploy it into the hybrid cloud. So in order to do that, we need to create a model. The model is a simplified representation of this application. As soon as we have an application model, we need also to provide the source infrastructure and the target infrastructure. In order to do that, we need to have a fine appreciation of the all infrastructure and to define it using some XML files, including the network topology, the computer resources, and all what we need to define an infrastructure in SimGrid. And using these 3 models, so it's a generic model. In order to cope with the real industrial output, we need to calibrate these models in order to have exactly the same KPIs in output. So if we have an industrial condition, for example, a given distribution of the response time, our simulation must provide the same distribution of response time in order to be okay. So starting from that, we can generate simulation scenario, and simulation scenario involve all the models that we create, and even can use real-world traces in order to replay it in the simulation and to see what will happen if this real traces will be deployed in the hybrid infrastructure and the cloud. The simulation itself, it's kind of very intensive HPC execution, and after that we have a lot of traces, and we try to pre-process these traces in order to recreate some KPIs. These KPIs allow us to evaluate and refine our results and to return to our stakeholders, the business stakeholders, and provide them with the output of our simulation to tell them this work, this topology or this deployment approach can work and this one cannot. And starting from that, they can make the business decision. Since it's industrial, the business decision is really independent from the performance. They can decide to deploy or not. It's their business, but we provide for them the information. If you have any objective, we tell them you can reach it with this infrastructure or not. And after that, it's not a research decision at all. So let's have an example. So here I will present an example of the hospitality management solution. Hospitality management solution of Amadeus. So there is some confidential information. I didn't show it, but I have the permission to tell about it. So it's the first worldwide deployed solution with more than 65,000 of hotel or hotel group using it in the world, representing 26% of all hotels in the world. And this solution, so if I provide simplified architecture, we have VIP customers. So it provides a backend solution for the management for the hotel. So it's not the front end, but it includes everything behind. We have a very aggressive SLA. So we will tell it V10, but it's an aggressive SLA. So our solution must respond in a really quick time. And if we consider this simplified architecture, so we have network service because main or big hotels are connected to our service using a direct fiber. We have also a management hub, we have a backend, and we have a backup. Because even if we have a very efficient solution, we always keep a backup, allowing them to have a continuity of the service even if we have any problem. And the target is to model the deployment of this infrastructure into a hybrid cloud. So this application is a very good candidate because first it's fully virtualized from the beginning. Second, because it uses private instance for critical customers, and because it uses a hierarchical redundancy mechanism to ensure the continuity of the service. So really, if we have a good model of this application, we can validate the efficiency of our approach. So how we start? We start with our stakeholders with a simple question about how if and the scenario. So here I provide two scenarios, the extreme one. So the one is that we will target the higher efficiency. And in this case, we deploy all VMs in one Azure site and with very low communication. So we buy the most expensive network solution from Azure and we connect this scenario to the customer. And this scenario is the most expensive one. Scenario 4, the application resource are deployed through several sites. VMs are randomly deployed in order to optimize the cost, and inter-VM communication is higher compared to scenario 1. Of course, we have some intermediate scenarios, but I don't have time to present that. It was in the paper, of course. So if we consider scenario 4, and if we focus on response time for search, which represents 75% an average of all requests received by hotels. So searching for a room represents the most of what the backend receives as a request. And here we see a comparison, distribution comparison between what Azure provides for us and what we have already in our current situation. So 1A is the name of the IATA name of Amadeus backend. Here we can see that Azure may provide acceptable response and even as efficient as what we have now. So with Azure, we are able to provide 90.5% of the transaction less than the SLA. The SLA agreement requires at least that 85% of the response of the requests are answered in this time, and 99% of response must be less than to the value of the SLA. So 85% and 99%. So what we see here is that Azure deployment, if we target the most expensive and the most efficient scenario, it's okay. We can reach the expected goal. And otherwise, if we target, if we consider scenario 4, when the simulated the solution is deployed in different VNet and in different sites in order to reduce the cost of the solution, we cannot reach the SLA as it is. We cannot provide 85% of the transaction lower than the SLA value. What is important here is that as soon as we provide this result for our business stakeholders, they know what is the cost of future deployment. They know if they can provide this solution for example, low cost package for some hotels that they accept to have lower price and lower performance, and VIP package for hotels that ask for really efficiency, whatever the price. And starting from this result, we are able also to predict the performance and the scalability. So based in what if a question, we are also able to provide some information about the load. The load, not only computing load, but also network load, system load. And if you consider here, for example, you see that in scenario one, we have how to say, low load of network. And in our agreement with Microsoft, the most expensive thing is network, is not compute. So here we see that there is not a lot of network compared to scenario 4, which represents more than 25% more network usage, because VMs was deployed in different sites. So there is a lot of inter-VMs communications. And here we can observe also that if we try to optimize compute, the overall cost is not really optimized. Finally, we will pay more for network and we will pay less for VMs, and we can provide a full package of the cost for our stakeholders. And in this case, what we see is that we provide a benefit of the Amadeus migration process. We have two kinds of benefits: technical benefits. So we can optimize the infrastructure migration. We can predict performance and dependency. We have also business benefits because we can enhance the decision-making process, and we can work on the cost reduction while still compliant with the SLA, whatever the agreement. So this was the most important benefit of Amadeus migration process for Amadeus. I present one application, but we use it for most of our application now, since we have a strategic partnership with Microsoft, and we start migrating most of our application to Azure infrastructure. When we talk about efficient infrastructure migration, we provide guided cloud-to-cloud migration process. We optimize and secure transition, and we save time and resources, because what we observe is that architecture stakeholders, technical stakeholders, what they do is that they buy the most expensive solution to be sure to provide the best service. And after that, after deployment, they start reducing their usage when they see that they are using a lot and they have unused VMs. So it's time saving and resource saving. We enhance the decision making because with this data-driven solution, our business negotiator can start with a strong position. They know that they can meet the SLA or not, and they know how to make the negotiation. So it's an informed choice. It's really a very good solution for manager and architecture to know what they want, what they need to do in order to reach the requirement. If we consider the cost reduction, so using Amadeus migration process, we reach 40 to 42% of cost reduction compared to, so when we say cost reduction, it's compared to what architecture do generally, what they generally start from a very strong position and after that they reduce. We maintain the same SLA for all our customers, and we optimize cloud architecture experts. Finally, so what is funny from a research point of view is that we are able to predict application behavior in the cloud, and we are able to identify performance issue and dependency to ensure an optimal application performance. So to conclude, the Amadeus migration process is a valuable approach to enhance cloud migration for modern application. Why I say modern application? Because we are focusing on application which was designed as a microservice pattern and which target hybrid cloud deployment. Amadeus migration process ensure continuous optimization through both predictive simulation and reactive adjustment, and the goal is always to ensure optimal performance with a good balance between performance and cost during and after the migration. We still continue optimizing this process So the next target is really to consider not only hybrid cloud, where we have Amadeus cloud, private cloud on one side and Azure cloud on the other side, but also to consider Amazon, because we start avoiding dependency. Okay, so we don't want to be really dependent on only one provider, whatever the problem, because we still may have problem from business point of view or technical point of view. So we start really considering different cloud providers. So yeah, this is it, and I hope it can help you to consider any migration process. It's really industrial approach, but it can be used also for big application and research also. Thank you for your attention, and if you have any question, I'm here to answer it.